So I'm going to do all four because I gave you the option. All right, so when it says draw one of the parent functions, this is what I was expecting to see, one of these. Can anybody tell me what this one's called? What function family is this one? Constant. All right, somebody else, what's this? What function family? Colby? Linear. All right, somebody else, what function family? Sean?
Absolute value.
Absolute value. What's this one?
Quadratic.
There they are. Those are the function families. Now I need a volunteer. I'm going to give you extra credit accountability points to come up and draw this. This is the hardest one, by the way. This is the one we're going to mess up. Draw it 5 units down. Who wants to pass it? Yes? Natalie? Who wants to open here one? Extra credit. Come up and draw it 5 units down. Yeah, go for it. It's okay if you get it wrong. You'll still get the extra credit. Riley, thank you. Who wants to do the absolute value one? Yep. Bailey? Right here. Quadratic. Sean?
Oh, I'm sorry. You're gonna miss.
I can kick you.
Again, you're still gonna miss. Yes.
All right, so for your number 2 homework, I just expect to see one of these. Now, I want to write the equations of these. Okay. So when I said this is the hardest one, I meant this is the hardest one to get the equation right. Anybody think they can get the equation right for this? Go for it. No, I'm gonna write it. You can just say it out loud.
Y equals -5.
Close. Close. That's what I expected you to do. It's actually -4. Because it's starting at 1 and then we're moving it down 5. So it's 1, 2, 1, 2, 3, 4, 5 would end up at -4. Right? So how about this one? This is y equals x. It goes right through the origin. If we go down 5, what will the equation be? Y equals x minus 5. So if you chose to do linear, write your equation next to your graph. Okay. Absolute value. What's the equation of this one? Absolute value of x. Minus 5 after it. You put a minus 5 after your equation, it's going to move it down 5. So what's the equation of this one? X squared minus 5. Okay. So our goal today is to take you from understanding the function families and the parent functions, using your vocabulary from geometry and from what I told you Friday, to starting to write equations that are different from the parent functions that are shown in pictures, or even you're going to draw the picture yourself, given different numbers in the equation. So moving from just graphs to equations. Does anybody have a question? Let's look at your homework, the handout 1 through 6. I'm going to show you the textbook answers, and I'm going to walk around and see what you did. So I don't expect your answer to be perfect, but you what I do expect is for number 1, you are able to say that yes, this is absolute value. For number 2, you're able to say yes, it is quadratic. The directions were to compare. So I wanted to see you write 2 units left, horizontal translation, 2 units left, 8 units down, something like that. Don't copy this word for word. Read it. Think about it. Good job, guys. I put on your syllabus to get red pens, and it was for this moment when you're doing corrections. Especially on quiz and test corrections, you want to have a red pen when we do quiz and test corrections. After comparisons, if you didn't quite get it, write some comparisons in. Read it, look at the picture, see how it relates. You can talk to the people in your group if you're confused. Any questions on 1 and 2? We're going to work on this today and tomorrow still, so it's a developing skill. Right here is 3 and 4. Number 3, if you were able to see that it was down from where the parent function would be, that's good. In the domain and range was talked about here, but it wasn't asked for in the directions, so I wasn't looking for it. Number 5, you did not have to do comparisons for. It was asking, given like a more complicated equation, can you figure out the function family? Number 5, f of t is negative t squared plus 22t plus 4. Anytime the variable is squared, call it quadratic. So when you see that t squared in number 5, that means it's a quadratic function. In number 6, linear. 10,000 minus 1250x. There's no absolute value bars. X is not squared. That means it's a linear function. And we're going to try to make some connections between complicated equations and their parent function. So. It's up to you how much of this you want to write down in your notebook. It will be very helpful. So, some kind of new notes here. We're going to talk about this for a while, and then we're going to do 3 examples. That's class. Okay, so these are models. What I don't want you to do, and you know yourself, I don't want you so busy writing that you can't hear or see, right? So if you need to sit back and just listen and then take a picture later, fine. Okay? You need to learn it more than you just need to copy it. Okay? All right. So these look similar. What looks similar about these 3 things, these 3 models? You go, yeah. So these are function families, but they're just expanded and more complicated. These are the parent functions, but they have an a value, a number in front of the x. They have an h value stuck in next to the x, and then they have a k value at the end. Okay? So which function family do you guys think this last one belongs to? Quadratic. So this is just a more complicated quadratic equation. And which function family does this one belong to? This is your absolute value model. And this one is linear. Because we don't see 2. The 2 means quadratic. We don't see x squared and we don't see bars. That's the linear model. Constant's not up here. Because like I said, right, like constant is just kind of boring. It doesn't have all this transformation stuff in it. Okay. So if any one of these 3 equations has a number in the a spot, let's say, for instance, your quadratic parent function is y equals x squared. If I put a negative sign in the a spot, for a, if a is negative, any guesses about what will happen if a is negative from this to this? There was one negative, I think, in your homework. What will happen if I put a negative sign in front of the x squared? What will happen to the parent function? What do you want to guess? No. That's still negative. It will show a reflection. Okay. It will cause all of the y values, instead of being positive, it's going to reflect it down. So if a is negative, then there is a reflection. Okay. Now, if there's a number in the a spot, so let's say, okay, here's the absolute value parent function. Let's say I put a number out in the a spot, like 3. Does anybody want to guess what that 3 will do to the absolute value? We did it, we talked about it Friday. I don't know if you can recall though. What will that 3 do? It's multiplication. So all your values be multiplied by 3. And what that's going to do is it's going to stretch it up. It's going to change the slope of the branch from up 1 over 1 to up 3 over 1. So it's going to make a skinnier graph. So if there's a number in the a spot that is greater than 1, then there is a vertical stretch. And the graph will appear skinnier. I had some good questions Friday. Like, how do I know if it's a stretch or a shrink? And that's going to start making sense now. If there's a number in front of the x, let's say this is a linear function. If I put 1/2 in front, the slope, this would be the a value. The slope would be up 1 over 2. And it would be a shrink. It would be a less steep graph. It would be shrunken vertically. So if a is less than 1, then there is a vertical shrink. H. H is a number that shows up in parentheses or brackets. H is the best one because it actually goes with the effect of the graph. H shows horizontal translation. But it's weird, it shows it opposite. We did an example Friday where I talked about how the 3 was opposite. Okay, one last value and it's K. If there's a number at the end, it's called K. And I think you guys can deduce what will K do. If there's a number at the end, how's it going to change the graph? You got it? No, who got it? What will a number at the end in the K spot do? For instance, all of our Bellworth examples, it'll move it up or down. So if I were to put a number at the end, not in parentheses, such as plus 10, 10 would be called a K value, and it would shift the graph up 10. So a K value shows a vertical translation. It moves it up or down. So you have a couple days to put this together, but given an equation, using these models, without seeing a picture, you can start to picture a graph, right? If I see x is squared, I'm going to think of a U-shaped parabola. And if there's a number here, I'm going to picture it up or down. If there's a number here, I'm going to picture it left or right. And then if there's a number out front, I might picture it skinnier or wider. That's our goal. Alright, so these are the 3 examples we want to do in class. Using that information, we're going to graph the parent function. So like I did here, these orange graphs. And then we're going to graph these equations on the same coordinate plane. So if you want to do these 3 on graph paper, you grab your graph paper today, it's a great time to use it. If not, you just sketch it on your notebook paper. Just take them one at a time. Don't feel like you have to set them all up right now. This is number 3 because it's the same examples as Friday. Okay. Starting with number 3 here. Let's start. What function family does number 3 belong to? Linear. Okay. So since our directions say to graph the parent function, let's just start with the graph, just sketch the parent function, the parent linear function. So this is the start. Graph the parent function. The more you graph those, the better you get at them. Eventually they'll be like incremental. Okay, it's y equals x plus 3. Are there parentheses in y equals x plus 3 as shown? There's no parentheses here. So would 3 be considered an h or a k? 3 is a k. H's are in parentheses or brackets. K's are not. So I'm going to look at this 3. I'm going to understand that it's a k value. And I'm gonna recall my notes. K value means a shift up or down. So it's a vertical translation of 3. And so now to graph it, I'm just going to take each point and move it up 3 places. That's it. That's what we're doing. Melanie, do you know which function family number 4 is? You got it? It's quadratic. And that's because there's an exponent of 2. There's an exponent of 2, we call that quadratic. So go ahead when you're ready. Draw the parent quadratic function. Hand out. You know it's helpful. So all the parent functions there. Use it. The more you look at it, the quicker you're going to memorize it. If you guys want to make a guess as to what the minus 2 will do, make a guess. It's okay if you get it wrong. You correct it. It's learning. So the parent function, I know. Goes to the origin. I know quadratic means a curved u, not a curved v. So the difference is inside the parentheses. So this minus 2 is not a k. K values move up or down. It's an h because it's in parentheses. Okay? So what does h do? It's going to move it left or right. Okay? When the number is in the parentheses or the brackets, the effect on the graph will be a right-left effect. Now it's opposite. So while all of my learning and knowledge up to this point would tell me that a minus should be going left, it's actually opposite. So this h value of 2 is actually going to move it to the right too. Okay. So if you didn't do this yet, you might want to go ahead and wherever you wrote your equation, label that 2 as an h value. It's not a k, it's an h. And h value is a horizontal slide. Horizontal slides are always opposite. So I'm going to draw this guy 2 units right. So we're learning to focus our eyes on where the numbers are and how that influences the graph. So the difference is I would have to, like in my table, I'd have to subtract 2 before I squared it. Whereas if it was a k, you would square it and then subtract 2, and that's the change. So as I walked around, I saw some people drew it left too. Very good, you went for it. Good. Just fix it, go right too. I saw some people go down too. Very good, you went for it. Take a look at why it's not down 2 and then fix it. Good to make mistakes while you're learning. Milena, do you know what number 5 function family is? What family does it belong to? Absolute value. This is an absolute value. So I'm going to start by drawing the absolute value parent function. And you guys, I keep changing colors because it's like so easy for me, but if you have highlighters and pens, this is a great time to use them. Do you have permission to use pen on this graph? You know, if you always want to do the parent function in red pen and then the new one in pencil, so it's like really clear what the change was, you can do that. Or even highlight the transformation. You just can't erase it. That's the only downfall. Okay, so this n of x, this function here called n, it's got a negative sign in it, and that negative sign is in the h spot because it's out in front. So if a is negative, then there's a reflection across the x-axis. So you're going to practice reflecting like you did in geometry. All of your points are just going to be across x. Alright, take your time, but when you're ready, flip over the handout from Friday. And your assignment today is 7 through 11. And I want to give you some pointers. Let me give you some pointers before I let you begin. I think you guys have 6 minutes to write some pointers down or get started on this problem. Any questions on this before I move away? You good? If you know you want a picture of the board before you go, you can get your phone out and take a picture of it. Take a picture of the models or any of this if that's going to be helpful to you. might have to extend. Okay, so if you draw it right in the middle, you're going to put the parent function on. So all of these are 2 lines. Now this one's -6. And I only have 1, 2, 3, 4. So if you need to draw your grid underneath or to the right or left when you go, that's fine. Don't feel like you did it wrong. You might need a little bigger picture. That's okay. So you're doing exactly what we did on those 3 problems. You do the parent function and the chain. Okay, 7 through 11. Which equations, there's 2 of them, don't answer that. Which equations have an H in them is what I was going to say. I think they have to install peepholes here. Yeah, or windows. Because I can't just open that door. I should have left some out there. He's the one that told us to do that. Okay. All right. Anyway, so this is an H value. So this is going to move your graph right or left. And this is an H value. And that's going to move you right or left. These are all K values, so they're going to go up or down. Hope I'm making sense right now. So I have to go to a whole new room. Where's 16?
Wait, so the next side of like a frequency is an H?
It's kind of by the gym.
It's
It's close to the gym area.
wait, also is that like after value? Yeah.
Okay, I'll start with the sign.
Yeah, it would be a lot. Okay. Anything?
Yeah.
Tonight, every 5 minutes before school.
I know preseason trainings for end of September, I think. So we have like, I think it's, I don't know, it could be earlier. I know it's at least. And then,
That's what it was last year.
yeah, I guess this is weird, but, well, I have to work. From 4:30 to 9:30 or 10:30.
Community service.
I have a job.
Public.
No. I don't host this at all.
Oh.
I'm not to fix it, it's minus thing, no one knows what it is. And there, and I mean, like,
Crop top.
I have to wear I mean, what it takes to get the bank. It would be terrible. That would be disgusting. My father would actually kick me out of my house.
But if you drive in someone else's Ferrari, what's the problem with Ferrari?
Exactly. To be honest, I have money.
You guys want to tell everybody that you know, instead of coming out here to 16. I guess they're going to have to announce it because the point is
But like classroom here?
The only thing I like about right here though is like right after this engineering.
Exactly. That's not.
I don't mind that.
Where's building 16?
I think it's by the gym. 17 is like right by the.
I've never been to 17 or 16.
I've never been in 17.
You're not.
Like,
Minus.
oh,
No.
okay.
They've only done this because of the lightning.
Oh, so they don't want us to get
They said there's more lightning coming. Like second period, there were kids like out here and the lightning was like here.
It wasn't safe.